Welcome to the Real Python Podcast. This is episode 273. What are techniques for writing maintainable Python code? How do you make your Python more readable and easier to refactor? Christopher Trudeau is back on the show this week, bringing another batch of PyCoder's weekly articles and projects. We discuss a recent article about writing code that is easy to maintain. We cover writing comments, creating meaningful names, avoiding magic numbers, and preparing code for your future self. We also share several other articles and projects from the Python community, including release news, modifying the REPL, differences between polars and pandas, generating realistic test data in Python, investigating Quasars with polars and marimo, creating simple meta tags for Django objects, and a GUI toolkit for grids of buttons. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Christopher, have you recovered from our news apocalypse from 2 weeks ago?
Almost. I think so, yeah.
All right, cool. We just have a couple minor stories this week. Got a bunch of good topics and discussion and projects this week, so ready to dig in?
Yeah. Every time I write up my notes for an intro for the news stuff, it usually starts out saying it's a light news week. And then something happens between me writing those notes and the show recording. So right now I have notes that say ad lib about whatever happened this time, but it's actually a light news week. Only two little bits. The first part is PyTorch 2.9 came out. I don't really operate in this space, so the feature list is more or less meaningless to me, but it looks like they've done some memory management improvements for multi-GPU kernels and some platform optimizations for both Intel and ARM. So it looks like they're chugging along and making it faster and better, as is usually the case with that kind of tool. And then the second bit of news is Django 6 Beta 1 came out. They're aiming for a release in early December. We've talked about what is in this release before, the big things being the background tasks mechanism and template partials. And now I'll leave you with a bunch of dead airs. We try to figure out what to do with ourselves having only two news items. There you go.
All right. All right, well, let me dig into my first topic then. This one's from Trey Hunter, who we've discussed multiple times on the show. And in fact, it's a topic that we've hit a bunch of times. We've discussed the Python REPL a lot. In fact, a lot recently because of the changes in 3.14, but also there's some changes in 3.13. Last year, 3.13 added some autocomplete stuff and other additions there, which were nice. 3.14 added the syntax colorization. Before I dig into his article, I want to mention a Real Python article that we've discussed before. It dug really deep into the REPL. Those of you who are new or just joining us for the first time, the Python REPL is the read, evaluate, print loop. That's the thing that you type Python into a terminal and it comes up and you can test your code and try out different things. Anyway, that article that Leodonis wrote went really deep into not only how to use it and all kinds of advice there, but also had a section about customizing it. There's this file that you can create called Python startup, all caps. He showed you that you can actually import packages with that. So in his particular example, he's having you import pretty print. If you're working with lots of dictionaries or JSON or some other things that might be useful. And then he also did a little bit of, again, this is before Python 3.14, he showed using the rich package to do colorization of the output. And it has a lot of details on that and how to kind of modify it. So I'll include that link. Trey's piece goes into customizing things at a slightly different angle. He loves the REPL. He uses it to test and explore code, just like many of us do. It's a great tool that's built into Python, but he especially likes to use it during teaching sessions. And he has written a startup file that modified key commands to allow shortcuts that help him. So when he presses home, it moves to the first character in the code block. Pressing N moves it to the last character in the code block. Pressing Alt and M moves to the first character of the current line. Shift Tab removes common indentation from the code block. Alt up does like a line swapping thing. Alt down does a one that moves it to the line below. Control N inserts a specific set of numbers that he has saved in there that you can use all the time instead of having to type that out, which I thought was interesting. And Control F is similar, but is in this case a list of strings. So these are things that he had built a really customized Python startup file for, and it was getting pretty elaborate or messy in his words, over like 100 lines. So he decided to make a library to assist in the creation of something like this for yourself. So if you wanted to build your own key shortcuts for your own startup file, it's called PyREPL-hacks. That's all together there, PYREPL-hacks. And it's on PyPI. And I'll include a GitHub link also so you can check it out. In the article, he shows the code that you would use to bind your own keyboard shortcuts if you're interested. And he shows how to implement it. He admits that it's really just a fancy wrapper around the underscore PyREPL and the underscore colorize modules. And I'll talk about the colorize in a moment here. He really wants to acknowledge there be dragons here. This process relies on the underscore PyREPL module that was added in Python 3.13, and then the underscore colorize module was added in 3.14. So if you're not using the latest version of Python, you might have issues trying to do this. So it's, again, bound around 3.14, and there's no guarantee that this might change in 3.15 or something later. So I like this line. Just be aware, here be private undocumented implementation detail dragons. So note the underscore in front of those modules. Those are things that are not intended for you to usually mess with. They're private kinds of things, and that's Python's way of indicating that to you if you're not familiar. So removing the Python startup variable, if you didn't want to do any of this stuff, would bypass all of this. He isn't using Windows, so he requests some feedback from the community about doing the key bindings with Windows. But a whole other tack that he takes in here is making it easier to do the colorization part that we've discussed off and on over the last several weeks. He actually adds some nice shortcuts in there. So if you want to hack your REPL or create a more elaborate Python startup file, I think it's a good resource. Also, kind of teaches some of the underlying workings here. So thanks, Trey, for this hack, if you will.
Have you been using the 3.14 REPL much?
Just off and on, checking out other people's code again, as I typically do. What are you noticing?
Yeah, I'm not sure if I've missed something or whether it's just sort of a side effect of the new feature, but now that up arrow creates the last block, well, if you've got a multi-line block, now you have to hit up arrow multiple times to get to the previous block before it, because up arrow now up arrows you into the block. So I don't know if there's another shortcut out there. I've looked and I didn't look hard, so maybe I missed it. But if somebody's listening that plays in this space, like control up arrow for the whole thing would be great. Because if I want to go back 3 blocks that are each 4 lines each, I shouldn't have to hit up arrow 12 times. So I don't know, for what it's worth. My plea for a feature or someone to tell me, hey, that already exists, you moron, didn't you read the docs? So whatever works.
Yeah. Do you modify your startup file?
No, I'm nervous about that kind of stuff. But that's a very old school thing. Having to move between multiple computers and different people's servers, I try to learn the existing shortcuts.
Yeah.
The more you modify it, the more you'll go, wait, how do I do that on this machine? Yeah. When you find you're not somewhere with your shortcuts, even with like Vim and things like that, I have very few keyboard shortcuts. Try to just learn how to do the stuff that's there rather than customize it.
I wonder if that is a thing that's happening now with a lot more remote type of work and remote opportunities, that customizing becomes less likely an issue of moving around. But when I was teaching at a school, we were teaching a lot of the software and they were filled with key commands, and it had entire sets. Like you could load key command sets in and out of stuff, like programs like Logic. And I'm in the same boat. Like, I'm like, how did you change this? All my commands now, I'm not zooming. What is going on here? And so, yeah, that's kind of frustrating, but I wonder if that allows you to do a little bit more of that.
Yeah, well, I've even had the other experience. So, like, there was an old command in VI that didn't get moved to Vim. And I set up a keyboard shortcut so that it would be in Vim, because that was the command that was in my head.
Yeah.
And I forgot about it. And like years and years later, it started to misbehave. And I start Googling, like, why isn't this working anymore? And of course, nothing's coming up. And it's because it's only on my machine, and I'd completely forgot that I customized it. And I'd submitted a question somewhere like Stack Overflow or somebody, and somebody was sort of like, do you mean these keystrokes? And then I was like, oh, wait a second. So sometimes customization comes and bites you in the big rear end. So
yeah. Another type of dragon that is hiding that you've built inside your own thing.
That's right. It's a tiny little dragon attached to my posterior. Yes.
Yeah, exactly. All right. So what do you got for our first topic here?
My first article this week is titled Polars versus Pandas, What's the Difference? And it's by frequent Real Python contributor Ian Eyre. Polars and pandas are both data frame libraries, which allow you to manage data as a series of rows and columns and then perform operations on it. It's kind of like having an in-memory spreadsheet. Pandas is the granddaddy of data frames in Python, while Polars is a more recent addition. The libraries have the same purpose, but their approach is a little different. And so this article compares them and helps you figure out, which you might choose or where you might use one versus the other for different things you're trying to solve. Let's start out with some of the similarities. First off, they both have data frame and series objects, the first being that row column thing I was talking about, and the second being like an ordered list sort of thing. To demonstrate this, the article starts out by showing you how to load a Parquet file. That's an open source data format, so think Excel. And you load that into a Pandas data frame. Pandas is index-based, which means when you look at the data you loaded, each item automatically gets an index value. If you aren't specific about it, it just uses an integer counter. Once you've got the data frame, you can then chain methods on it, like creating new columns based on existing ones, returning a subset of columns. This is known as a filter. That can be a little confusing because it's used to mean something else in Polars. But anyways, returning a subset of rows based on a query string, say like total is greater than 100. And there is ongoing work in Pandas around chaining, as they've kind of been inspired by some of the ideas in Polars and are adding similar concepts in coming versions. The next step in the article is to perform the exact same data operations, but in Polars. Polars does pretty much everything through chaining. One of the first things you'll notice, though, is it doesn't have an index. So that index thing I was talking about just isn't there. You can still access any individual row using square brackets. So if your default index in Pandas is just the integers, then you can do the same thing, but you can't do it as keys or other pieces. I mentioned in Pandas that you can specify a query string like total greater than 100. In Polars, you actually use a Python expression instead. So you use a column accessor, then the greater than sign, and 100. The big advantage to this approach is syntax problems get caught when you're typing things in rather than when the query is being executed. Doubly so if you're doing this in an IDE where you get access to the type hint information. See, I'm not always down on type hints. The article goes on to cover a few more things, like how you do plotting in both of them, how Polars supports importing Pandas data frames in case there's a Panda feature you need access to. Spoiler alert, we'll talk about that later. And the last thing I'm going to touch on, which is being lazy. There's a little bit of irony here in the fact that the data frame library named after the laziest bear on the planet, the panda, doesn't actually support lazy execution. And in case you're yelling at your headphones right now, koalas aren't actually bears. So although they're far lazier, they don't count.
They have pouches, right? They're marsupials.
They're marsupials. I seem to recall reading that they actually get high on eucalyptus, which is why they sleep all the time. But nice. That might just be an urban legend. So anyways, what was I saying? Right, Polars. So Polars supports lazy evaluation. What that means is that you can build queries without executing them. You chain them together, then fire the execution all at once by calling the collect method. The big advantage of this is performance. Say you're filtering data and running a calculation on the filtered data. By filtering during the load, you don't have to actually load unused data into memory. You can just throw it out and then do the calculation on the filtered stuff. This can make a big difference. In pandas, if you do this out of order, the whole thing gets run. In polars, if you do it lazily, the query optimizer figures this out for you. This, to me, is the killer feature of polars, and it's why it's my personal preference. That, and well, I'm Canadian, so I kind of have to love the polar bear. It's a national pride thing. They're on our money for, it's a thing. Anyways, all told, a great article by Ian, lots of good examples, and there's a lot of links in here as well. So as you're digging through, if there's more you want to read about, he points you at other places to read even more. So if you're thinking of switching libraries or trying to figure out which one is best for the work you're doing, this is a great place to help you make that decision.
One of the things he mentions at the top of it that I didn't dig into a whole lot is that the built-in plotting library for pandas is matplotlib, which I think we've known about, and it's sort of built in a way that you can kind of just plot from a data frame and has methods and stuff. But he was mentioning that Polars has Altair built in, and I was like, is that new? Is that recent? And so I wanted to learn a little more about that. I'm not sure if it was there by default back in the day.
I think it's been around for a while. If I remember correctly, Polars supports like 4 or 5 different libraries. They just don't ship. So there's like a shim for them.
Okay.
So you can get into the other places if you want to.
Right.
Yeah, because I remember when I first started playing with polars, I went to graph something and I was expecting matplotlib, and then it was like, oh, it's this instead. And then I started digging a little bit and was like, and they support a couple things that I had never even heard of. So there was a bit of a rabbit hole there. I find I don't plot directly from this stuff anyways.
You'll choose something specific.
If I'm plotting, I'm going into Marimo.
Oh, okay.
Right. So if I'm playing the data straight, then like I'm in a REPL or something like that, then it's fine. If I'm starting to get graphical, then I'm pulling out into a notebook anyhow. And Marimo supports matplotlib, so that allows me to go there. So, it just kind of depends on what you want to do.
Yeah. Marco Gorelli, the guy who created Narwhal, speaking of another animal,
yes,
did a lot of work to make sure, the translation between all these data frame libraries is there. And I know originally the Altair thing was a big deal for them to kind of get it supported. So yeah, it's great to see all this work kind of continue on. And even though they're different libraries and you might have choices for one or another, it's nice to see that they can interoperate fairly well now.
Yeah.
Too.
Well, and Polars has a from pandas method as well.
Yeah.
And we'll be talking about this shortly, but one of the things I've done is, I need this thing that isn't in polars, and it's a 2-line pandas call. So I will do it in pandas, get the data frame, then convert that into polars, and then go back to my preferred library. So there's a fair amount of interoperability without even, touching narwhals and the other pieces. So so there's a lot of choice.
So yeah, stay tuned. All right. So my next one is about generating fake data. It's by Quinn Tran, who I have as an upcoming guest on the show. In fact, I think next week. And it's on her Code Cut blog that we've referenced a few times on the show. The title of the piece is Faker, Generate Realistic Test Data in Python with 1 line of code. And I think we've discussed this library many years ago here, maybe 4 years ago. What I like about this particular piece is it's tightly organized around the common things that you would do with Faker. As an example, she gives at the beginning of it, you want to create data with very specific data types. You want bools or floats or text or integers. And then you have special characteristics that you want, like they need to be names or addresses or colors or email addresses, phone numbers or locations. So she walks you through in the article. It's a fairly tight piece, like I said. She walks you through installing, importing the library, and then making a few items using methods after you build a fake class. So like, as an example, it would look like fake.color_name and calling that particular method, or fake.name or fake.address or fake.job, which I didn't know. That's kind of interesting one. And then date of birth and city. It was funny because the first example she pops out, and her name is Deborah Armstrong. She lives in Beanview. Her favorite color is green, yellow, and she's a lawyer or whatever, that kind of thing. The other example she had was a systems analyst, and they were born in 1946. I'm like, that's interesting. Anyway, here's where I dug into a feature I was not familiar with, that you can localize the fake data that actually has background for a variety of countries and other locales inside there. So you could say something like, oh, I want the fake names based around Italy. And so you get Federica Iacovelli. And so I thought that was really kind of cool. Same with cities or from various countries. And then text, you can do kind of the lorem ipsum thing, but you can say, I want it to be in a specific language. So you can do fake.text. So not only can you specify the language, but you can also build your own sort of lorem ipsum text that you would like it to use. You specify all of that into a list of the words that you would like to be used in your own lorem ipsum. And then in the keyword variable, ext_word_list equals, and then you'd have your list name, like my_words or whatever. The article continues on. This is a very popular tool in two places that I'm familiar with. One is just building data for like a data frame, like building example stuff to run your code through to make sure it works. I've seen it being used in data science quite a bit. And then in true testing, something she doesn't get into, if you go through Faker's Read the Doc site, Faker's documentation has the ways that you would connect it to something like PyTest. That might be another resource that you look at. I will include a link for it also. At the very end of it, she demonstrates building a pandas data frame, staying on theme here, with like 100 users from different countries. So you can kind of see it in this larger example. Thanks, Quinn, for this nice tour of using Faker.
I wish I'd found this years ago. I have a spreadsheet kicking around with, I think, close to 100 Simpsons characters in it. And and it's like multiple tabs, and the tabs specify who's in what family, because I was working with a client and we had like one of those where there were multiple logins and each login had to know who the brother was, right? There were relationships between them.
Sure.
So I had this basically multifaceted database of fake data based on Simpsons. It took a long time to put together, and this sounds to me like I could have used this library for 5 minutes and got those hours of my life back, but it is what it is.
Probably brought a smile to everybody who's using it, though.
Yes,
so.
Well, there's that, yes.
It's time to shine a spotlight on another Real Python video course. Linting is essential to writing clean and readable code that you can share with others. A linter, like rough, is a tool that analyzes your code and looks for errors, stylistic issues, and suspicious constructs. And this video course is titled Modern Python Linting with Rough. It's based on a Real Python tutorial by Ricky White. And the video course is presented by Rodrigo Yirao-Serrao. And in it, you'll learn how to install Rough, check your Python code for errors, automatically fix your linting errors, and use Rough to format your code. And you'll also learn how to add optional configurations to supercharge your linting. I think it's a worthy investment of your time to learn how to use a modern linter that's extremely fast and has a simple interface, which is what makes Rough straightforward to use. Like most of the video courses on Real Python, the course is broken into easily consumable sections, and where needed, you get code examples for the techniques shown. All of our lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com. All right. The article we teased about is coming up next here. What do you got?
Yeah. So last year, Giuliano Denuno and I worked together to create a couple of courses. Giuliano's an astronomy research assistant, and the courses were on space stuff and, of course, Python. One was on Astrolab, which is an astronomy toolkit, and the other was on using pandas and matplotlib on astronomy data. Internally, we called that one Pandas in Space, which anyone of our age group will get that reference, and everyone else is going to wonder why I did that. Anyways, we enjoyed doing it so much that this year we've done another one. It's called Investigating Quasar Data with Polars and Interactive Marimo Notebooks. The title's a bit of a mouthful, but hey, that's how we get things found by search engines. So this is a practical course, sort of a how-to kind of thing. that shows you how to build an interactive Marimo dashboard containing Redshift data about Quasars. So the course starts with a bit of science background so that you understand what the data is all about. I'll give you the quick version. So quasars are what happens when a black hole eats something. They're the most energetic things in the universe, with the big ones at the centers of large galaxies outputting more energy than the sum total of stars in the Milky Way. So these are phenomenally large energetic events. The course looks at the spectral output of quasars, that's all the different energies at each frequency, and graphs it. So the other bit of science you need is redshift. When something emitting a wave is moving relative to you, the frequency of that wave appears shifted. When this happens with sound, it's known as the Doppler effect, and you experience it when a fire engine goes by. The pitch of the siren seems to change as it passes. Due to the expansion of the universe, and that's an oversimplification, but let's stick with it, most quasars are moving away from us. The energy they emit gets shifted because of this motion. The shift is towards the red end of the light spectrum, hence redshift. So by determining the redshift, you can figure out how far away a quasar is, which tells you how long in the past the light was emitted. You figure out its redshift by looking at spectral lines of known elements. So let's say you're looking at the hydrogen being emitted, then you compare the hydrogen line you see with what it should be, and however much it's been shifted, that gives you the redshift. So that's the basic concept. The course shows you how to build a Marimo notebook containing the spectral graph of a quasar, then add overlay lines of the elemental items, and then interactive GUI components that turn these lines on and off, say like the hydrogen I just mentioned, and a slider that moves those lines determining their redshift. So essentially what you're trying to do is map up those lines with the observed quasar data in order to figure out what the redshift is. This is all a gross oversimplification, but hey, if I told you all about it, you'd have no reason to take the course. So along the way, you'll learn how to query spectral data from a free astronomy dataset, how to take that data into polars and put it in a form you can use in Marimo, how to fetch elemental spectral data from a web page using pandas, then convert it to polars for the notebook, how to graph all this stuff in matplotlib, and of course, how to build interactive Marimo notebooks to put all this together. This was a really fun course to create. If you're interested in the astronomy stuff, then there's plenty here for you. If you're just looking for a good example of fetching and cleaning and dealing with real-world data, then you can get that here as well. So I hope you enjoy it.
Yeah, it was a fun course to review, and I love seeing the interactivity of Marimo, and gives you an example and a tool to play with. In fact, you can research other quasars and learn their redshift using the same tool, which is pretty cool.
Yeah, and I was actually surprised at just how responsive it was. Like, we're redrawing matplotlib graphs on the fly as you move a slider around, and it pretty much keeps up with you. So it's a fun little toy.
Yeah. So we have a discussion this week about writing maintainable code. This is a piece that's by Patrick Altman. It's on Wedgeworth Technology. The title is Crafting Software, Writing Maintainable Code. So I'm thinking maybe that's a series of crafting software. It's a non-exhaustive list of techniques to keep in mind for keeping your software maintainable. So I'll list a lot of them. A lot of them probably sound familiar, but it's more of a starting point for us to kind of discuss some of these things. I will introduce a bunch of them for us, and maybe, I don't know, you want to interrupt me, feel free as we go. The first one they mentioned is commenting code as being one of the easiest things to do, but it's also one of the easiest things to do wrong. Two main audiences they're listing here for comments: external developers, people coming to your code, or maybe they're now becoming internal. Good doc strings help developers to understand the API. And then, as you were mentioning there about type checking earlier, editors that support IntelliSense or features like that can grab those doc strings and then bring them up in an editor and actually show you this information, which is really nice. So again, it could be internal coming in and seeing the code for the first time, but also it could be other people that are using your code or looking at it and trying to understand it. Other developers within the same code base, including yourself, your future self, who have to maintain the code. You're like, what did I do there? And so, yeah, comments are good there. The trick is keeping them to a minimum, keeping them to a length that makes sense. Lots of advice is out there on this sort of stuff. I think we've written an entire piece about it on Real Python. Maybe I'll include a link for it. Comments need to be updated when you make changes to the code. So they are kind of a bit of a thing that you have to keep in mind. If you're going to change your code, you got to make sure that you're looking at the updates. Their suggestion is explain why, like what is it doing, giving context for your decisions as opposed to explaining step by step what the thing's doing. That's where I think comments kind of get out of hand.
Yeah, you see, particularly with new developers, junior developers, you'll see something like X plus equals 2, and then the comment says add 2 to X. Well, that doesn't help anybody, right?
Right, exactly.
And this is one of those things, a lot of developers are very anti them, keep them to a minimum. I honestly tend to move a little towards more comments than I think the average developer does.
Yeah.
I embrace the idea that you have to maintain the comments. I see it as maintaining the code. For me, I find no matter how good your code is, the cognitive load of trying to read the code and understand what it is in comparison to an English sentence is always higher.
Right.
So if I'm trying to skim quickly and I can read a sentence that, hey, the next 10 lines of code does this, and I don't have to dig into that, it means I can move on. And of course, the downfall of that is there's a chance that comment doesn't match those 10 lines. So people do have to be religious about it. Personally, some of this I think is just the way my brain works. So it's quite possible that other people look at this and go, I don't know why you do this. But I often find that, like, if I'm going to write 10 lines of code, the first thing that's going through my brain is, well, what am I trying to do? So I have to write a little story, and it doesn't have to be a lot. It's a sentence or two. The next chunk of code is going to do this.
Right.
Well, if I write that comment first, I find it helps my brain go, okay, and this is what I have to do.
Yeah, I was going to ask you about this.
And so then it's there. And then I'm basically kind of codifying what the comment is. And the irony of all this is, we've gotten to this stage where everyone's like, well, the comments aren't helpful, whatever. And now we're into the LLM world. And what are you doing when you're prompting the LLM? Well, you're trying to find a good sentence to give it that explains so it'll generate the code. Well, if you can do that, you can write the comment because that's what that comment is. But
yeah,
I think I've stepped up on my soapbox. So
No. I see this as a teaching technique often. Again, I'm newer to Python than you are. And so I was watching lots of tutorials and stuff like that. I'm very much a video person. And I would see people go through this step of like, okay, this is what I want to try to do. And they would write out the chunks of like comments before writing the code, plan it all out. And it's kind of weird because it is very much a full circle kind of thing. Like I have a conversation that's coming up about spec driven development, which is this term that is kind of silly in a sense that we've had to codify it, because we were talking about behavior driven development and all these kinds of things. But this idea of documenting, well, what is a code supposed to do is actually pretty critical. And having it within your code is actually vital also for finding structurally where things are within your code and lots of different things there. So I think, I don't know if you do that whole process of writing out all of it, or is it more just right before you write some of the code, you sort of explain what it's going to be?
No, it's more of a chunk at a time.
Not like a whole thing.
It's not perfect, but let's say I was going to write a 10 or 20 line function, then a comment at the top that this is what this function is going to do. It's kind of like a lightweight version of TDD, right? So with test driven development, you're going to write a bunch of tests that say, okay, this function will work when it passes these tests. Well, that can be a little bit of a heavyweight, particularly if you haven't figured out exactly what the interface is yet. But writing a sentence or two in English, and particularly if it's going to be a publicly consumed function, then you can put it in the PyDoc of the function because you said this function is going to do this, and that how. And again, this I do recognize that this is a personal thing, so other people may find this different, but I find that helps me think about what it's going to be. And then the other part I do is where something gets messy, right? So when there's something that's not obvious, if I have to do something trickier, I'll find sometimes you'll do something that, you'll be working on the code and you have to do something in a non-obvious way. You have to come back and make a change to it, or you try X and it fails for some reason, and then you come in and try to do Y instead. Well, it's a good idea to write yourself a little comment, because when you come back 6 months later, you go, well, why didn't I do X? That's the obvious way.
Again, the notes to yourself.
So negative comments can be really, really helpful.
Yeah.
The article also mentions one which I like. particularly if you're in a professional setting, is linking to your issue tickets. So if you're fixing a bug and you need to go in and muck with something, put in the line that says, hey, this is connected to ticket number 1234. Well, then that allows another developer to go back and look up ticket 1234 and see exactly like the full repro sequence and all the rest of it.
Yeah.
So I find that's a nice little thing to sort of do as well.
Yeah, I think about like what you're saying as you're deciding to do this, leaving hints like this is potentially areas where I want to refactor.
Yeah. Similarly, a developer I'm working with is using a library of mine for the first time, and he sent me a whole bunch of questions the other day. And about half the answers to the questions in my mind were, okay, that's a sign that my documentation sucks. Because I know I could tell he'd read the documentation. So if he's asking me that question, I thought that was in the docs, but he's read them. So I got to go back and do that. And so whether it's the docs or the comments, and this is another thing that's in the article, which is, if you're doing a code review and someone says, well, why did you take that approach? Well, that's probably a good place to go back, and it might still be the right approach, right, but that might be a good place to put in a comment so that, again, 6 months from now, when somebody goes, well, this is stupid, before they go and redo it, a little bit of a description as to why you did it that way might make them go, stop. It might save them a whole bunch of time, because they might take them 2 days to go down the same path you just went down in order to discover the thing you did, right?
Yeah, totally. So the next one is about a design concept. It's the single responsibility principle. We've talked about this. And in fact, you have a course where you kind of dive into some of this stuff based on an article by Leodanis. They state it's a pretty well-known one, not limited to object-oriented design. A unit of code should have a single point of responsibility. In Martin Fowler's book, he talks about actors and relationships to them, but I think it is simple enough to think about having a single concern. Code is harder to understand if a function has multiple concerns and more likely to maybe have side effects. Kind of a note there about going back to the idea of refactoring, of like maybe decoupling code during refactoring and thinking about it. So you've talked about this before a lot, so I don't know how much you want to get into it.
This kind of comes back to that conversation we were having a couple of weeks ago about taste. Like this is one of those things where it's like, it's usually fairly obvious once you've gotten in the habit of, oh no, I'm doing too many things here. But it's very much a sort of, I know it when I see it. Side effects are problematic. It tends to make it hard to find bugs, right? So that loose coupling can be helpful about that. But it's very hard, I find, to give abstract advice on this. This is a code review kind of advice. This is having a mentor go, maybe you should divide that up into two.
Yeah. It's doing a couple things here.
Yeah, and you sort of learn about that as you go. Sometimes it's unavoidable, and I guess that's that taste thing, is trying to figure out when you have to and when you can't.
It kind of leads into the next one, just to jump into it. It's about naming things that are having meaningful names. Use names that are meaningful but short. If you're going to name something and it does two things, then that's going to be, it's harder to name it. Yeah. So that might be a clue there. They mentioned, variables, classes, property names typically should be short nouns, the things that you're working with, whereas methods or functions, they should be verbs describing the action that they're doing. Realizing naming isn't easy, it kind of goes back to that, but maybe that could be a hint to you that, hey, maybe you're not following some of these other rules. Along with it not being easy, it's still worth the time invested. The place where I started to see this, I was reading a lot of Apple documentation. I was interested in iOS. It was one of the first areas I kind of dove into before I actually got into Python. I was like very excited about the idea of making programs that could run on your little handheld computer walking around. But their names were like really long, like verb-like sentences strung together. And so I don't see it as much in the real world.
Apple tends to be extreme about it. You see it a lot more in GUI toolkits.
Okay.
Because it's harder to describe. Like, once you get past button, like,
yeah.
Okay, what is a panel? This is a panel, but there's a grid panel. So then, you find it starts to turn into German, where you've got like 4 or 5 words squished together to create a compound word. Again, this is a bit of a know it when you see it. It makes it similar to that comment thing I was talking about before. This makes your code far more readable.
Yeah.
but it takes a lot of mental energy. So a lot of people kind of skip past it. And then I've also seen the other direction of it. Like, the abstract advice here is, don't name the variable X. Well, yeah, but if it's a loop variable and all it is a counter, there's nothing wrong with calling it an X. It's a balancing act.
It's like the underscore being used sometimes.
Yeah.
That could be confusing, though, sometimes for people who are not familiar with it.
There's an old joke, which is there are two hard problems in computer science: cache invalidation, naming things, and off by one errors. This appears to be attributed to Leon Bambrick, but it's been kicking around so long I've seen it attributed to Abe Lincoln as well. It is an old joke and it isn't all that funny, but it's kind of telling that naming things is identified there, right? So right back at the beginning, and if you go back far enough, compilers had limits on how long your variable names could be for memory optimization purposes. So that used to be even harder. And, if you've got a function that's got nothing but alphabet letters as all of your variables, it starts to become hard to track what these things are.
About 10 years ago, I got really interested in the concept of a reverse dictionary. You ever heard of this concept? Yeah, I think maybe something like that would be useful, where you're kind of typing the definition and it finds the word. And that might be useful in that, or I'm still experimenting with LLMs. Maybe that would be another useful kind of thing where it's good with language. So maybe it could help you with some of that stuff about finding, ways to define things.
So back in the old days, those single letter variables, it was quite common to see a little mapping dictionary in the comments at the top. So if I can't name it number of cars because that's too large and I've got NC, then there's a comment above the function that says NC is the number of cars, which kind of that mapping concept that you're talking about. You're talking about going the other direction, but yeah. So even when there were restrictions on this stuff, people were careful about it because it makes the code harder to read.
Yeah. Quantify cars.
Yes.
Yeah, actually, that kind of leads to the next thing there. No magic numbers, a very strong statement there. There is never a good argument for unnamed constants in the code. If you're entering into your code these constants as an actual value, it leads to it being not as maintainable. And the suggestion they provide here is just collecting all of them into, in this case, like a constants.py like module that, depending on the size of your project, that you can kind of then just import that in and keep things tidy. But yeah, it depends what the level of the code is. If you're working with a script, then it probably makes sense to maybe just have the things at the top of the code. But I get it, like if you're using a larger example.
Yeah, to me, I'm not a big fan of the common file. I think it's useful in certain situations, like configuration type stuff. I think it should go with the place that's being used. So for example, if you're doing redundant code that does a lot of retries everywhere, then I want a common file with something that has a value defined as num retries.
Right.
And because if I want to change it from 3 to 5, I shouldn't be looking through the code for every 3 or every 5. It should be in a common place. So that's kind of the driver behind it. But I don't tend to pull it out into a common file unless it's going to be used across multiple files. Otherwise, I want it with the code.
And you'll define it at the top of the code.
To me, it tends to be, I do my imports, then I do my constants that are defined for that. And one of the things I still fight with myself is, when is my constant at the top of the file and when is my constant an attribute of my class? And I switch back and forth. Sometimes it makes sense to be part of the class, but then you have to type so much more in order to get it in. So I tend to waver back and forth. I'm never happy with that.
Yeah. The other thing they get into is testable code. I'll just read this paragraph from the start of the section. I'm not a test-driven development champion. I know we aren't supposed to admit this, but in the 20 plus years I've written software, I can count the number of times that TDD felt worthwhile on one, maybe two hands. So after saying that, he mentions keeping testing in mind throughout coding, sort of asking questions of yourself. Can these services be mocked in a test? Can I decompose what I'm writing into smaller units that are easier to test? Can I isolate difficult areas? Maybe that leads to comments that, again, you're kind of answering as you go. And also leads back to sort of the single responsibility in a way. I feel like I don't think you're a test-driven development champion.
His flavor is very similar to my approach.
Yeah.
I think I'm a little more OCD about my coverage levels than he is from what he's described.
Yeah.
but I very seldom start purely with the test. I tend to write it as I go along. He does say something that I really liked, which was keeping the question, how would I test this, in mind while you're writing it?
Yeah.
Because there are sometimes when you write a function, if you're not thinking about it, you might actually be making it hard to test it. And
not untestable, but like difficult to.
Yeah. And in fact, I've seen this with clients with large code bases where, they don't have a lot of test coverage and they want to do some refactoring. Well, the first thing we do is, let's go write some tests so that we know that refactoring isn't going to break it.
Yeah.
And then you're like, well, I can't touch that because it's going to touch this server, and I can't touch that because it has this side effect. And I was like, okay, well, now what ends up happening is you have to refactor the code so that you can write the tests, and then you write the tests in order to actually do the bigger refactor, right? So it's definitely something you kind of want to keep in mind.
Yeah.
Along with the TDDs zealots, I've met dependency injection zealots, that code must be structured this way because that's the right way to test it. I find that tends to be in other languages than Python a little more frequently. Because Python's got the mock, you don't have to do it as much. But as much as I don't necessarily use that approach myself, the question you're asking yourself of how do I structure my code so that I can test this, which is where the heart of that idea comes from, is a good one.
Yeah. It's funny because a lot of this stuff, the theme, right, is how to write maintainable code. And a big part of it is this idea of like, okay, well, during the maintenance phase of keeping this going is refactoring. And so a lot of these ideas kind of lead back to that.
There's nothing like having to maintain someone else's code to teach you these lessons.
Yeah. Easy to read is the next one. And I'm just going to highlight the two things mentioned, which are code block lengths and then kind of avoiding too much branching, ways to be able to just follow the code. I mean, the comments would maybe help with some of this stuff, but also just being able to like, I have done that before where, the suggestion people have often is like, okay, go look at other people's code and kind of understand what's going on, some of your favorite packages and so forth. And you're like looking at it and you're like, well, where does that go?
A good rule of thumb here is if it doesn't fit on the screen, you're going to lose it because you have to remember the stuff that was on the previous screen in order to understand what is happening on this screen. So if it isn't fitting on a screen, so you're in that kind of 20 line ballpark, then you might want to break it down. The only counter to that, particularly in Python, is function calls in Python are expensive. So if you're doing high-performing code, sometimes you have to break this rule in order to get things to be a little more optimal. But don't use that as an excuse to write 1,000-line functions.
Yeah. The next one is dry, the don't repeat yourself. It's a classic principle that's been out there. He mentions the book, The Pragmatic Programmer, which he highly recommends. I'll try to include a link here for that also in the show notes. If you find yourself copying and pasting code, you might not be following dry. Are there several very similar pieces of code? Maybe you could look at doing a single abstraction. I don't know if there's much to say there, but yeah, I mean, if you're copying and pasting and moving your code around, it's just, you have to learn this. You have to learn ways to sort of do that. And I think that would probably come up pretty quickly in any code review you'd have with other people. So future thinking is the last one, and sort of considering yourself, being kind to yourself, and might wanting to leave things in a way that if you knew you're going to come back to it in several years and have to fix something under a tight deadline, how would you want to leave the code in that way? I feel this way about my whole life. Like I want to leave things in a better shape than I found it.
Yes.
And I'm baffled by the amount of human beings that do not care about leaving things, in a good shape.
It's the Boy Scout rule. Leave the campground cleaner than you found it. Yeah.
Yeah.
There's another one of those Abe Lincoln quotes that I think is attributed to a gentleman named John Woods that I've always liked, which is always code as if the guy who ends up maintaining your code is a violent psychopath who knows where you live. So code for readability.
Yeah.
And of course, if you happen to be a violent psychopath, then, you've got that whole, you might be angry with yourself later. So always remember, future self is the enemy of your current self, and you may be maintaining it yourself.
Yeah, definitely. This kind of went in some fun directions. I like having these discussions and kind of thinking about some of these concepts a little bit deeper. If anybody has suggestions for other things you want us to kind of dig into or articles you want to share with us, please reach out. Chris and I are both on social media. We don't mention this often. I think a lot of people just follow the real Python accounts, and it's like, that's not usually getting to me. If you want to follow me, I'm at digiglean, DIGIGLEAN, on things like Blue Sky and also on Mastodon. And Trudeau's out there too, if you want to share yours.
I'm on Blue Sky at trudeau.dev, TRUDEAU.
All right, so that gets us into projects. I guess I'm going first. So this is from friend of the show and frequent guest, Al Swigert. I've been seeing him working on this via some social media posts kind of related to what we were just mentioning there. It's a project. It's called buttonpad. It has a subtitle of GUI, Graphical User Interface Toolkit for Grids of Buttons, going back to your button naming earlier. It's built on top of tkinter. Again, that's something that's built into Python as a GUI if you haven't played with it. Again, we got resources at RealPython for that. And that's it. It's a GUI toolkit to get you quickly started building graphical user interfaces that use lots of buttons. And you go, well, what can I do with that? There's some examples, and it's nice the code includes all of these different examples, even ones that he's not using as visualizations. And in this particular GitHub post, there's even more inside of it. Some of the fun ones that I thought I would use, there's some games, 2048, sliding numbers puzzles, but there's standard button types of things like a calculator, and how would you code that? If you're looking for projects that you might maybe use or play around with or show other people, there's a stopwatch that's in there. The one that I liked a lot is actually something that I have a problem with, which is getting to emojis. I don't really like the emoji picker that's built into iOS or Apple stuff. I can't find it, what I'm looking for often. And I'm Gen X. I have maybe 5 go-tos here. So there's maybe 25 that I use. Anyway, I was going to ask you, what are your emojis, Christopher?
I think there's 25 versions of Pi. We discovered that recently, let alone.
Yeah, going back into that. Yeah. So the idea here is you can make this pad of ones that you can call up very quickly and copy and paste them. Like clicking on them, it moves them to the area where you can paste them in there. I'm not an emoji wizard. So anyway, I thought that was a fun example inside there. The documentation is really good. The examples are really well commented for you to follow along and go through. So if you're looking for a quick way to create a graphical user interface and make your code a little more visual, I think this is a great project. So thanks, Al. What's your project?
My project this week is called Django-snakeoil, and it's by Tom Carrick, who goes by Nighty with a K and 2 Ys. Of course, how else would you spell it? Let me just say that as this is a tool to help with metadata that primarily gets used by social media sites and SEO, man, do I love the name. If you're not familiar, there's an HTML tag called meta, which is kind of an all-purpose tag that you use to give the browser or scraper information about your page. Its most common use is for places like Twitter and Facebook to show previews of your page when they construct links. So when if you see something on Blue Sky where it's not just the URL, but you see the little preview, it's the meta tags on the page that are providing that information to Blue Sky. A common construct on a Django site is for a page view to be associated with an ORM object from the database. So say you're viewing a blog page, that blog entry might be in the article object in the database. And when you hit a URL, it's looking up that article object and displaying its contents. What Snakeoil does is provides tools within the Django object itself to represent the kind of data that goes in those meta tags, and then template rendering tags for presenting the associated data. It kind of works like a dunder string method, but instead of returning a string representation, you're returning a dictionary with the data for the tag, which it then renders on the page for you. As this gets done in a method on your object, you can, of course, dynamically determine what the contents are based on the object itself. So say you've got that article, you might have its title, the associated author's name, and your preview image to associate it if you want, and all that goes in the dictionary, and then Snakeoil takes care of rendering it for you. So if you're doing Django things and you've been handcrafting your meta tags or maybe ignoring them altogether, well, then this library can help you out.
Nice. Yeah, I like the Snakeoil name. That's good. All right. Well, thanks, Christopher, for bringing the news and all these topics and projects this week.
Always a pleasure.
I want to thank Christopher Trudeau for coming back on the show this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.